Hello, I'm Desmond Edagese. Welcome to Maths class. Today, we'll be taking exercises. We'll be learning how to make use of logarithm in calculations for numbers less than 1. Before we go on into our class, there's a quick thing we need to take note of. We learned earlier that to find the characteristic of the logarithm of numbers, we simply find the number of zeros between the decimal point and the first significant number, and we add 1 to it. We said that number is negative, but the negative sign is annotated with a bar. So for instance, we'd have bar 2 instead of minus 2. Though it is negative, we also need to take note that the negative value affects just the integral part. The fractional part of our given or our obtained log number remains positive. Because of this fact, calculations therefore, such as multiplications and divisions with bar notations, are very peculiar. Let's take some typical examples that we'll find in the course of our exercises that we'll shortly go into. Let's take, for instance, we have bar 2.5 multiplied by 3. To do this, in order not to have errors or mistakes in our work, we'll simply break this number up into its integral part, which is bar 2, and the fractional part, which is 0.5. And we'll go ahead to do our multiplication here, which is by 3. When we are done, we'll add up our gotten values to give us a certain number. Let's go on and work this out. So we have 3 times bar 2, which is the integral part. That would give us bar 6. We'd also multiply 3 by 0.5, and that would give us 1.5. If we add bar 6, remember bar 6 is negative 6, while our 1.5 here remains positive. We would have bar 5, that is minus 6 plus the 1 here, which is the integral of our number, and that would give us minus 5, which is written as bar 5. We'll be left here with 0.5, and here we have 0.5. If we add up our values, bar 5 plus 0.5, we would have bar 5.5. Let's take a look at another typical example. Bar 8.4 divided by 2. Again, we would break bar 8.4 into its integral part and its fractional part. So the integral part is bar 8, while its fractional part is 0.4. So once again, we'll carry out our calculation here. Bar 8 divided by 2 would give us bar 4, while 0.4 divided by 2 would give us 0.2. So we have bar 4 and 0.2. We'll simply combine both numbers here, bar 4 and 0.2, to also give us bar 4.2. Again, let's take a look at another typical and a little more complex example. Bar 4.7 divided by 3. Once again, we'll break this down into its components, which is the integral and the fractional part. So bar 4 and 0.7 would be the component of our number bar 4.7. Let's quickly carry out our operation. 3 in 4 would give us values with remainders and all of that. But we do not want a remainder. We want a value that we can go into and divide and get a number without a remainder. So what do? Remember, we have bar 4 separate and 0.7 separate. Our bar 4 here, which is same as negative 4, but of course it affects just the integral, could be gotten if we simply added minus 6 and plus 2. We can also use other numbers. Say, for instance, minus 8 and plus 4. This would also give us minus 4. And so on and so on. You can think of so many combinations. But we need a combination that is simple one, and also one that would help us divide our 3 without a remainder. And of course, this would be a good bet. Minus 6 and plus 2 if added up, would also give us minus 4. So instead of writing minus 4, we could simply write bar 6, which is our minus 6, and 2. 2, of course, will come to the fractional part. So instead of 0.7 here, we have 2.7. So we have our minus 4, or our bar 4, as bar 6 and 2. Now, this value is the same as our value here. We're simply writing it in a different manner so that we can easily carry out our division. So simply we have, now 6 divided by 3 would give us 2, which of course has no remainder, and it's pretty easy to do. 3 also in 2.7 would give us 0.9. And hence we have our components. So we have bar 2 and 0.9. Once again, we just combine both values, and that would give us bar 2.9 as our answer. In the course of our exercises that we'll be going into shortly, we'll come across many of these kind of situations. So it's very important that we know exactly how to tackle them when we get to them. Let's go on. Let's take some examples. We'll be looking at examples that involve operations such as multiplications and divisions. Of course, we are working with numbers less than 1, and we are making use of our logarithm table. So again, let's start by solving 5.339 times 0.006942 divided by 0.0255. To do this, remember in our last class, we advised us that we'll simply lay out a neat table that has number and logarithm. Let's go ahead. So we have 5.339. 5.339, if we find the logarithm of 5.339, would have as our integer 0. Remember, to find the integer or the characteristic of numbers greater than 1, which 5.339 is of course greater than 1, we would simply subtract 1 from the number of digits in the integral part of our number. We have 1 digit here, so 1 minus 1 will give us 0. So we have 0. The fractional part will simply look up from the logarithm table. Let's quickly do that. So we have 5339. The first 2 digits is 53, and we'll look up our next digit is 3 from our column 3 to trace down our row 53 to get 7267. The last digit is what? 9. 9 we will look up under the difference column to give us 7 if we traced it down to meet our row. So 6267 plus 7 will give us 4. 7274. So we have 0.7274 as the logarithm of 5.339. Next we have 0.006942. To do this of course is a different case from the first instance. In the first instance we had a number greater than 1. This of course is less than 1. So the rules are different. To get the integral of this part, we'll count the number of zeros as 1, 2, which is between the decimal point and the first significant figure. We have 2, so we had 1. So we have 3, which of course is negative and annotated with a bar. So we have bar 3. Point a fractional part. The fractional part will also simply go to our logarithm table to get that. So we have 6942 as our number string. We'll quickly get 69 on our row 69. Trace down to row 4 to give us an intercept of 8414. And of course, the last digit is 2, which is traced to give us 1. So we have 8415. And here we have it. The logarithm of 0.06942 is bar 3.8415. Now we have to add up the both logarithms that we've gotten from the numbers on the numerator of our problem. So we'll simply add 4 and 5 to have 9, 7 and 1 to have 8, 2 and 4 to have 6, 7 and 8 to have 15, so 5. 1 is carried over. Here we have 1 plus minus 3, which of course is 1 minus 3, which of course is what? Minus 2. But we annotate this with a bar. And that's why we have bar 2.5689. We also have our denominator here as 0.0255. the logarithm of 0.0255 would give us, remember the integral part again, 1 0 between the decimal point and the first significant figure would have 1 plus 1 to give us 2. 2 is negative, annotated with a bar, so we have bar 2. The fractional part we'll find from the logarithm table, and that will give us 4065. Now we will subtract because we have a division here. So if we subtracted this, bar 2.4065 from bar 2.5689 would have 9 minus 5 would give us 4. 8 minus 6 would give us 2. 6 minus 0 would give us 6. 5 minus 4 would give us 1. Bar 2, which is minus 2, minus 2 would be minus 2 plus 2. Of course, this would give us 0. And that's why we have 0.1624. That's our number. But remember, the number that we seek is the anti-logarithm of 0.1624. So to get our number, we need to find the anti-logarithm of our value there. Let's quickly get that. 0.1624 is our number string. So we have 0.16 as the first 2 digits on our anti-log table. If we trace that, we would have 2, which is the next column, to intercept our row, and that would give us 1452. The last digit on our number string is 4. 4 is looked up under the difference column. Trace down to meet our row where we have a value 1. So we add 1 to that, and we have 1453. So we have 1453 as our number string. But remember, in our last class in SS1, we learned how to find the anti-logarithms of tables. We said the anti-logarithm is simply the number that we have as the integral part of our given number plus 1. And we said whatever that value is, it becomes the number of decimal points that we have after our first value. So we add 0 plus 1. That would give us 1. It means that this number string would have 1 decimal point before the other values. So this becomes 1.453. And that is our given number. We can use a calculator to do a quick check, and we'll find that our answer is always correct up to 3 or 4 decimal points. Let's take a look at an example that involves roots. If we're asked, for instance, to solve using mathematical tables the fourth root of 0.0008. To do that, quickly, we'll lay out a table neatly that has 2 fields, number and log. We'll find the logarithm of 0.0008. To do that, we'll first get our integral, which is our characteristic, to be the number of zeros between the decimal point here and the first significant figure, which is 8. We have 3 zeros. So we add 1 to 3, and that would give us 4. But remember, we said the characteristic of numbers of logarithms less than 1 is negative. So we have minus 4, but the minus or the negative value is annotated with a bar. So we have bar 4. The mantissa part is simply looked up from a logarithm table. To do that, we'll simply look up the value 80 from the logarithm table. The logarithm of our number string 80 is found on our row 80 under the column 0. The intercept is gotten at this point with the value 9031. So we have the logarithm of 0.0008 as bar 4.9031. But remember, we are looking for the fourth root. To write this in index form, we could simply rewrite that as 0.0008 raised to power 1 over 4. If we work this out, using the laws of indices, we would have our value here, which we've gotten as the logarithm of 0.0008. That value is bar 4.9031. So we have bar 4.9031 divided by 4. But we learned earlier that for such an instance, we need to break this, our value here, into this integer and mantissa part. So we have bar 4 and 0.9031. All of that divided by 4. Bar 4 by 4 would have bar 1. And if we divide 0.9031 by 4, we would have 0.2258. We'll simply combine these values, bar 1 and 0.2258, to give us bar 1.2258. Now, the number that we seek is the anti-logarithm of bar 1.2258. It therefore means that we need to go to the anti-logarithm table to get the value that we want, using the number string 0.2258. Let's quickly do that. On our anti-logarithm table, we'll quickly locate the row that has 0.22. Trace it down to intercept our column, which is the next digit on our number string 5. They would intercept at this point that has the value 1679. If we continue our trace down, and also intercept the last digit on our number string, which is 8. 8, of course, is found under the difference column. We would have an intercept at this point that has the value 3. If we sum that up, we would have 1682. And there we have 1682. But remember, the integral part of our log number here is bar 1. We need the value there to be added to 1, which would give us a value that we'll finally use to indicate the number of digits on our final answer here that would come before the decimal point. Let's quickly do that. So bar 1 plus 1 would give us minus 1 plus 1. Of course, that is 0. It therefore means that we would have 0.1682 as our final answer. So the fourth root of 0.0008 is 0.1682. To confirm this, if you have a calculator, you can quickly do a quick calculation and you'll find that you have the same answer, correct to the 4th decimal place. Let's take a look at this example here. We've been asked to solve, using mathematical tables, 7.329 times 10 raised to the power 6, all raised to the power 3. To do this again, we simply lay out our table. 7.329 times 10 raised to the power 6 would give us, as logarithm, the integral part. If we lay this out, we would simply have our integral as bar 6. This bar 6, of course, is minus 6, but of course we annotate it as bar 6. The power that we can see in the standard form that is our question is an indication of what our characteristic is. So we may not need to go through some long process. By merely looking at the power in a standard form, we know exactly what the characteristic is. So in this case, we have our characteristic as bar 6. The fractional part is what we now go into the logarithm table to find. So we use our number string 7329 to get that fractional part. 73 or 73 is traced on our row to meet the next digit on our number string, which is 2, at this point where we have a value 8645. The last digit on our number string is 9. 9 is traced down under the difference column to meet our row where we have the value 5. So we simply add this up to have 8650. We have 8650, and therefore we combine this to be bar 6.8650. Now all of this, if we remember from our question, is raised to a power 3. It simply means that our value here, which is bar 6.8650, is multiplied by 3. By the laws of indices, which we learned long ago, we multiply our value here by 6. From what we learned earlier again, we'll simply need to break this into its integral and its mantissa. So we have bar 6 plus 0.8650. all multiplied by 3 separately. 3 times bar 6 would give us bar 18. And 3 times 0.8650 would give us 2.5950. Minus 18, and the integral part here, which is 2, would give us minus 16. Minus 16, of course, is annotated with a bar, so we have bar 16. And we have our remaining parts here as 0.5950. If we combine both there, we'd have bar 16.5950. Again, the number that we seek is the anti-logarithm of our gotten value here, which is bar 16.5950. So to find the anti-logarithm, we simply use our anti-logarithm table to find that. So we have 0.59. We trace that on the row and find the next digit, which is 5, under our column here. So column 5 traces down to meet our row at this point, where we have a value 3936. 3936 is our value. But remember, we learned that in standard form, the power that is seen in that standard form is an indication of what the characteristic is. And we have bar 16 here as the value of our number from whence we are getting the anti-logarithm. It simply means that our gotten number would be 3.936 times 10 raised to the power minus 16. And that is the number that is the answer to our problem here. I hope it was clear enough. As we look at more examples, it will become obviously more clear. Let's go on. Let's try some exercises to see how far we've learned from the examples we took. Now, if we were asked to solve using mathematical tables, the cube root of 349 divided by 2,608. We said our first step would be to lay out our solution using a table with fields number and log. Quickly, we'll write down 349 and we'll find the logarithm of 349. To do this, the integral part or our characteristic would be what? 1, 2, 3 digits minus 1, which would be 2 points. Next, we'll find the mantissa using the logarithm table. 34 is traced on our row down to column 9, which is the next digit in our number string. The intercept of row and column would give us a value 5428. So we have 2.5428. Next, we'll find the logarithm of 2,608. Again, the characteristic of our number here would be 1, 2, 3, 4 digits minus 1. That would be 3, which is also positive. Point the fractional part. The fractional part, again, we'll simply look up from our logarithm table. Let's quickly do that. So we have row 26, our column 0, to intercept our row, which would give us the value 4150. The last number on our number string is 8. 8 is looked up under the difference column to trace down and intercept our row to give us a value 13. So we'll simply add that up to give us 4163. So we have the logarithm of 2608 as 3.4163. Now we're doing a division. Hence, we would have our operator here as minus. So we minus 3.416 from 2.5428. Let's quickly do that. We'll have 5. We'll have 6. We'll have 2. We'll have 1. And here we'll have bar 1. 2 minus 3 would give us minus 1. But of course, we learned that we annotate our negative value with a bar. So this instead is written as bar 1. That's why we have bar 1.126 and 5. All right, next, remember we're finding the cube root. In index form, this same question could be rewritten as 349 all over 2,608, all raised to 1 over 3. To write our value here in index form, since we already have a value for 349 divided by 2,608, which is bar 1.1265, we'll divide all of that by 3. And quickly we learned that we would need to break this down into its integer and mantissa. To do that, we would have bar 1 plus 0.1265. All of that divided by 3. But notice quickly that 3 cannot go into our bar 1. So we need to find two values that we can use that can substitute our bar 1 here. We could have minus 3 and plus 2, which would of course give us minus 1. Our minus 1, of course, we annotate as bar 1. So minus 3 and plus 2 could be used to substitute for our bar 1. Let's quickly do that. We would have bar 3 plus 2.1265. All of this divided by 3. Let's quickly do our division here. We would have bar 1 plus 0.7088. 3 goes into our bar 3 to give us bar 1, and 3 goes into 2.1265 to give us 0.7088. All we need to do hereafter is to combine our bar 1 and our 0.7088 to give us bar 1.7088. But the number that we seek is the anti-logarithm of bar 1.7088. So, therefore, to get that number, we simply look up our value from our anti-logarithm table. Let's quickly do that. The number string we'll be using is 0.7088. And hence we have our 0.70, which are the first 2 digits of our number string. Trace down on our row to meet our column 8. 8 is the next number on our number string. They intercept at this point where we have a value 5105. The last number on our number string is 8. 8 is looked up from the difference column. If it is traced down to meet our row, we have an intercept at this point with a value 9. If we quickly sum that up, we would have 5114 as our value. So we have 5114. But remember, the integer of our value here, which is bar 1, is used to trace the number of digits we would have in our final answer before the decimal point. We have minus 1 as our value of the integer of our number here. Minus 1, therefore, is added to 1, and that gives us 0. Hence, we have 0.5114 as our final answer. Let's go on to look at another example. Let's take a try at another exercise. If we were asked to use the logarithm table to evaluate 4.3 squared times 5.912 divided by the square root of 0.3749. Again, remember our first step. We'll lay out a table that has 2 fields, number and log. First, we'll find the logarithm of 4.32 squared. Let's do that. To get this, the integer part or the characteristic of our logarithm here would be 1 digit minus 1, which is 0. So we have 0. Next, we get our mantissa from the logarithm table. Let's quickly do that. So we have 43, which is the first 2 digits of our number string. We find that on our row, the row of our logarithm table, trace it down to intercept the column 2, which is the second digit on our number string. The intercept would give us a value 6355. So we have 0.6355. Remember, it is raised to power 2. By the laws of indices, we simply multiply this by 2. This, of course, would give us 1.2710. Next, we'll also find the logarithm of our second number here, which is 5.912. The integral part of our logarithm number would be 0. Next, we'll find 5912, which is our number string. We'll get the mantissa from the logarithm table. Let's quickly do that. Again, the first 2 digits is 59, which is found on the row. If we trace that down to intercept our next digit, which is 1, we'd have an intercept at this point with the value 7716. The last digit on our number string is what? 2. 2 is traced down also to intercept our row at this point with the value 1. So we have an addition of both values to give us 7717. Hence, we have our logarithm number as 0.7717. Since the operator between both numbers is a multiplier, by the laws of indices, we'll add that up. So we need to add 1.2710 and 0.7717. That, of course, would give us 2.0427. That is the value that we have for our numerator in our question. Let's keep that value down somewhere. So we have 2.0427. Next, we need to find the square root of 0.3749. Let's do that. We'll have 0.3749. First, let's get the logarithm of our number here. To find the characteristic or the integral part of our logarithm number from this value, we would have, remember we said we need to count the number of zeros between the decimal point and the first significant figure. We have 0 number of zeros here. So we have 0 plus 1. That would give us 1. And of course, we said that 1 is negative, so it is annotated with a bar 1. Our mantissa part again, we will look up simply from the logarithm table. Let's quickly do that. So our number string we would use is 3749. From our logarithm table, we trace the first 2 digits, which is 37. The next digit on our number string is 4. We trace that down also to have an intercept at this point. Our value there gives us 5729. If we continue to trace, to intercept the last digit which is found under the difference column, we'll have an intercept at this point with the value 10. If we sum that up, we'll have 5739. So we have bar 1.5739. But remember that we're looking for the square root of 0.3749. What we have is just the logarithm of 0.3749. The square roots could be rewritten in index form as 0.3749 all raised to the power 1 over 2. Again, if we worked this out, we would have, since we already have a value as bar 1.5739, we would divide this by 2. To do this, from what we've learned so far, 2 cannot go directly into bar 1. So we need to find 2 values that we could use to replace our bar 1, which is also a negative 1. So we could have minus 2 plus 1 would also give us minus 1, which we annotate as bar 1. So we are going to replace our bar 1 here with minus 2 plus 1. or in simpler terms, bar 2 and 1. Let's rewrite this, therefore. We would have bar 2 plus 1.5739. All of this, again, divided by 2. This would give us a value, bar 1, that is 2 in bar 2 will give us bar 1, and 2 in 1.5739 would give us 0.7869. If we combine these values here, we'll simply have bar 1.7869. Let's write that value also down somewhere special. So we have bar 1.7869. Now from our question here, our numerator is divided by our denominator. In indices, we would subtract denominator from our numerator. So we would have 2.0427, which is the value we got earlier for our numerator, minus bar 1.7869. Let's quickly do that subtraction. We'd have our value as 2.2558. That is the value that we have. But the value or the number that we seek after is the number that is the logarithm that we've seen so far, which is 2.2558. It therefore means that what we want is the anti-logarithm of 2.2558. Therefore, we would go again to the anti-logarithm table to find a value for 2.2558. Let's go straight to our anti-logarithm table. We'll use our number string 0.2558 to do our search on the anti-logarithm table. So we have 0.25, which is the first two digits in our number string. The next digit is 5. We look that up from our column and intercept our row at this point. The value we have there is 1799. The last digit on our number string is 8. 8 is found under the difference column. That is traced to intercept our row at this point with the value 3. Hence, we have 1802 as our number. So we have 1802. But remember, the integral part of our logarithm number here is 2. To find the number of digits that would come before our decimal points, we'll simply add 1 to the integral part here. That would give us 3. 3 therefore means that whatever number that we have as our anti-logarithm would have the first 3 digits of that number would come before the decimal point. So we have 1 decimal point, 2, and 3. Our final answer therefore becomes 180.2. And that is the answer that we come to get. In summary, we've looked at exercises making use of logarithms in calculations. And remember, we are working with numbers that are less than 1. Let's see again if we remember all the steps that we took while carrying out these calculations. We had different types of operations. We had multiplications. For multiplications, we said first, you set out your solutions neatly in a table with headings, number, and log. Next, we find the logarithm of our numbers. And remember, we said that for numbers that are less than 1, we have peculiar nature of characteristics with bars or negative numbers which we annotate as bars. So we take cognizance of those forms in our calculations. For example, in multiplication, it involves addition. When we add, remember we said sometimes we need to break our numbers into the integer and mantissa to simplify our work. Finally, we find the anti-logarithm of whatever sum that we get to get our final answer. For questions that involve division, again, we said we need to set out our solutions neatly on a table with headings number and log. Next, we find the logarithms of the numbers to be divided on separate rows, and we subtract them. Again, we take into cognizance the fact that for numbers less than 1, we have negative characteristics that do not affect the mantissa that remains positive. So we remember that in our calculations. And finally, we find the anti-logarithm of whatever number we get from our subtraction to get our final answer. For numbers that involve powers, we go through the same steps of setting out our solution neatly in a table with headings number and log. We find the logarithms of the number base and multiply them by the value of our power. And finally, we get the anti-logarithm of whatever number we have to get our final answer. For questions that involve roots, we again set out our solutions neatly in a table with headings number and log. Next, we find the logarithm of the number base and divide them by the value of the root, that is the nth root. And finally, we get the anti-logarithm of whatever number that is our answer to get the final answer. With all that we've learned today, I'm very sure that when next we come in contact with questions that involve logarithms for numbers less than 1, it will not be a problem for us. I look forward to seeing you in my next class. Bye for now.